welcome to episode 8 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so interesting to astronomers. So let's run the random number generator. The coordinates that came back this episode are 20 hours, 57 minutes, 23.6 seconds right ascension, and plus 17 degrees, 7 minutes, 45 seconds declination. These coordinates point to the location of an object called 2 Zwicky 96 in the constellation Delphinus. That's a Roman numeral 2 and regular digits for the 96. This is one of many objects outside our galaxy that was initially identified in surveys by Fritz Zwicky in the mid-20th century. As a side note, Fritz Zwicky is one of those people who could be accurately described as an angry scientist as well as a mad scientist. The object is a pair of galaxies at a distance of about 520 million light-years, or 160 megaparsecs, that are in the process of merging together to form one larger galaxy. 2 Zwicky 96 is one of many galaxies classified as a luminous infrared galaxy, which astronomers often abbreviate and pronounce as LIRG. LIRGs are defined as galaxies where the total amount of infrared light from the galaxies is equivalent to somewhere between 100 billion and 1 trillion times the amount of light produced by the Sun. In space, infrared light is primarily produced by interstellar dust. The dust absorbs ultraviolet and visible light from stars and other astronomical objects and then re-emits at infrared wavelengths. This happens in our galaxy and in many other galaxies, but the amount of infrared light that is produced is kind of wussy compared to LIRGs like 2 Zwicky 96. The huge amount of energy radiated as infrared light by interstellar dust in LIRGs needs to originate from a very strong energy source. One possibility is that the energy comes from a large number of very bright, very hot stars. Since these stars have very short lifespans, they are usually indicative of where star formation has taken place very recently, and if an abnormally large number of stars appear to be forming in any one location, it's usually referred to as a starburst. And these starbursts can provide all the energy that is absorbed by interstellar dust and re-radiated as infrared light in LIRGs. The other possibility is that the energy comes from an active galactic nucleus, or AGN, which consists of a supermassive black hole and a large disk of gas and dust that gets very hot as it slowly falls into the black hole. The disk itself would produce a lot of infrared light, and if the AGN is surrounded by even more dust, this will absorb extra energy from the disk and re-radiate it as more infrared light. In LIRGs powered by starbursts, the stars typically form in the center of the galaxy or the multiple galaxies in the system, making these locations the brightest infrared sources in the galaxies. In LIRGs powered by AGN, the AGN is by definition found in the nucleus or the centers of the galaxies, and so is most of the infrared light. However, 2 Zwicky 96, like its namesake, behaves differently from other LIRGs just to aggravate astronomers. Most of the infrared emission in 2 Zwicky 96 comes from a location in the outskirts of one of the two galaxies involved. The centers of both the galaxies in 2 Zwicky 96 don't really produce that much infrared light in comparison. The discovery of this off-center infrared bright region in 2 Zwicky 96 prompted astronomers to investigate what the heck was going on, whether it could be powered by a starburst or an AGN, even though the AGN would not be in the nucleus of either galaxy, which would seem to contradict the definition of an AGN, and maybe means that it should just be called an active galaxy something or other. With the use of mid-infrared spectroscopy, it's possible to investigate what's happening in places where the interstellar dust obscures all of the visible light, and when the mid-infrared spectrum was made of the infrared bright thing in TwoSwiki 96, astronomers saw no sign of an AGN being present. They also made estimates of the rate at which stars are forming. Astronomers like to describe this rate in terms of the mass of gas in units of the mass of the Sun or solar masses that is converted into new stars per unit time. If all of the infrared emission comes from a starburst, it looks like up to 120 solar masses of gas per year could be forming into stars in this weird off-center region in TwoSwiki 96. For comparison, the star formation rate for the entire Milky Way is a relatively wimpy 1.65 solar masses per year. However, astronomers can also see through interstellar dust using radio telescopes. And a group of astronomers used the Merlin telescope, now called eMerlin, to observe regions called masers.
Woohoo! Masers!
Within TwoSwiki 96. And that sound effect is my coworker Adam, who particularly likes studying masers.
Woo!
Masers
Woohoo!
are like radio wave lasers in space. And by observing the motion of these masers in TwoSwiki 96, Merlin was able to show that the off-center region in this galaxy might contain a very compact object about 1 billion times the mass of the Sun. This would mean that a supermassive black hole could be present, and that people may need to find a name other than AGN to describe things that contain supermassive black holes. So as far as I can tell, people are still trying to figure out exactly what's happening in TwoSwiki 96. And I think some astronomers would be interested in trying to model the system to figure out what the heck the infrared bright thing is, and in particular, whether it could be a third galaxy actually hidden behind the first two. In any case, TwoSwiki 96 shows that sometimes the brightest infrared sources in luminous infrared galaxies are not the centers, but strange regions in the outskirts. A lot of astronomers debate exactly what's happening inside LIRGs, with a particular focus on how much star formation or AGN are involved in producing the large amounts of infrared emission from these galaxies, but things like TwoSwiki 96 just make those debates even more confusing and weird. So the location on the Earth's surface that corresponds to the position of TwoSwiki 96 on the sky is the Mid-Atlantic Ridge between the Caribbean Sea and Mauritania. This gave me the thought that I could actually relate the location on the Earth's surface a little bit more to the object in the sky. And if I had been more clever, I would have also done this in episode 6, because that would have been really cool with that object. But anyway, when you think of TwoSwiki 96, you can think of the large amounts of explosive energy in TwoSwiki 96 being equivalent to the large explosive amount of energy that you see in the Mid-Atlantic Ridge. And similarly, there could be stars forming in TwoSwiki 96, just like portions of the Earth's crust are forming in the Mid-Atlantic Ridge. Having said that, though, the analogy begins to break down if you start to think about it too much, because with TwoSwiki 96, we're talking about things falling inwards, although the starburst or the AGN or whatever is going on in TwoSwiki 96 would also push stuff outwards. But there's both an inwards and outwards motion, whereas the Mid-Atlantic Ridge is just moving outwards, and also, of course, the Mid-Atlantic Ridge, by definition, is in the middle of the Atlantic, whereas the thing in TwoSwiki 96 is on the outside, and so it just gets weird, and so don't think about the comparison too hard, but do try to associate both things with lots of extra explosive energy. If you like this podcast, the website for the podcast is www.randomastronomicalobjects.com, which you can visit to download episodes of the show, read information about the objects talked about in the show, view images of those astronomical objects, and send me random feedback. And in fact, I got my first random feedback this week, which wasn't a blank message. it was spam. Please feel free to send me real feedback, though. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Hendy at www.sasha-hendy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The special guest sound effects are from Adam Avison.
Mazes.
And the other sound effects are from the Freesound project at www.freesound.org. Thanks for listening.